Today we'll be talking about Lewis structures. We've talked about chemistry in various forms. Wanted to play around with Lewis structures. Later I'll be cooking, so I've got these tongs here. I guess I'll be juggling them too, but I can use them for a pointing here. All right, so Lewis structures. If you take a look here, we've got the electronic octet, which is the key to the Lewis structure. I've got 5 simple steps. Valence electrons, drawing the skeleton, excess electrons, satisfying the octet, total electrons, sort of a checking what you've done in the last 4 steps, or in the first 4 steps, I should say. All right, so let's build a few of these things. Here, nitrogen and 2 oxygens. All right, so NO2, let's take a look at this one. How do we put this together? Where does the central atom go? Well, that's pretty easy. It's going to be with nitrogen. Why? Because we've got 1 nitrogen and 2 oxygens. Wouldn't make much sense to put one of the oxygens in the middle. Nitrogen in the center, and a couple of oxygens surrounding it, over here, and another one over here. Okay. NO2, nitrogen dioxide, you can call it that. There are various ways to name things. Common names versus the International Union for Pure and Applied Chemistry, IUPAC names. All right, so we've got nitrogen in the center, 2 oxygens. What about the valence shell? 6 in the oxygen shell, 6 in the oxygen shell. 6 plus 6, 12. 5 in the nitrogen shell. 6, 6, 5. If my math is correct, that would be about 17, okay? 17. Yes, at one time Dr. Bones was 17 years old, but that was many eons ago. But don't worry, I'm still having fun. All right, so nitrogen. In the center, total is 17. Octet is 8. 17, 8. One's odd, one's even. Doesn't look like this would work from the octet rule. And it won't, but it'll still hold together, and we'll tell you about what's called the incomplete octet. All right, so here we go. You ready? We've got our bonds. Let's put 2 electrons here, another 2 over here. And instead of putting more bonds, let's start putting some electron dots in here. All right, so we know that oxygen has the potential for 6 valence electrons. So let's do this. Let's have some fun with these ceramic magnets. Kind of difficult to pull apart here, but they're very good. They hold on. And we'll do another 6 here with oxygen. Got some more of these. All right, 2, 4, 6. I enjoy these things, but they're difficult to pull apart. And 1 more here, and finally 1 more. Okay, here we go. So, thus far, looks like we've satisfied the octets, whoops, over here, on the oxygens, but definitely deficient on the nitrogen. But we need to do a count here, first of all right? We need to find out how many electrons have we done thus far. We said that there are 17 total valence electrons. Thus far, I have 2, 4, 6, 8, 10, 12, 14, 16. So there's an electron that goes somewhere. Can't go with the oxygens. They've satisfied the octet. It's got to go here with the nitrogen. However, we're still deficient here. What are we going to do? What will you do? Well, guess what? We can create a double bond either here or here. Yes, this will be a resonance structure. We've talked about this before. A neat resonance structure to consider is CO3 2-, right? The carbonate molecule. Very interesting. So one of these is going to have a double bond. Let's put it over here. All right, so what we're going to do is take these 2 electrons, move it over here, creating a double bond. Here, let's just make this look a little more symmetrical. So we've got a double bond on this side of the nitrogen and a single bond on this side. We've got all the electrons, though. All right, let's do the count. 2, 4, 6, 8, 10, 12, 14, 16, 17. So there it is, and we've satisfied the octets for the 2 oxygens. What about nitrogen? 2, 4, 6, 7. So it's deficient by 1. This would actually be a bent structure, all right? And it's called an incomplete octet. So the octet rule is not always satisfied in every molecule. Sometimes we have deficiencies. Sometimes we have something which we'll review shortly called an expanded octet. So NO2, incomplete octet, 17 electrons.